A single photon leaving the surface of the sun takes about 8 minutes to reach your eyes. But before that, it spent over 100,000 years bouncing randomly inside the sun, just trying to escape. That is one layer of reality buried inside a star. But what's even crazier is that this is only the beginning of a structure that goes so deep, so strange, and so far beyond what your senses can register, that most of it may be permanently invisible to you. Layer 1 is the quantum foam. This is the smallest scale physics can currently describe, a proposed texture to space itself, so tiny that a single proton would look like an entire universe next to it. At this scale, distance and time may stop behaving like a smooth fabric and start behaving like static, flickering in and out in bursts smaller than a trillionth of a centimeter. No smoothness, no continuity, just churning uncertainty. Physicists estimate this happens around the Planck length, a unit so small it has never been directly observed, only calculated. And if space itself is grainy down there, then everything you think is solid, your hand, this screen, the ground beneath you, is built on top of something that never stops trembling. That trembling foundation leads to layer 2, the layer of particles and forces, the world of quarks and electrons bound by 4 fundamental forces that hold every atom together. Take away the strong nuclear force for even a fraction of a second, and every atomic nucleus in your body would fly apart instantly. No stability, no chemistry, no you. This layer was mapped out piece by piece through the 20th century, with the final major piece, the Higgs boson, confirmed in 2012 after decades of searching. It's the layer that makes matter possible. But matter alone doesn't explain why the universe has structure instead of being an even, boring soup of particles. For that, you have to go up, not down. Layer 3 is atomic and molecular structure, the point where quantum rules start producing something you can actually picture. Atoms bonding into molecules, molecules bonding into the chemistry of stars, planets, and living things. A single water molecule is built from just 3 atoms, yet the specific angle between them, about 104.5 degrees, is the reason ice floats instead of sinks, which is the reason oceans don't freeze solid from the bottom up. Small numbers, enormous consequences. But here is the unsettling part. Everything at this layer, every element heavier than hydrogen and helium, was forged inside the extreme pressure of a dying star. You are, on a chemical level, made of stellar wreckage, and that wreckage assembles into something far more dangerous the higher up the scale you go. Layer 4 is planetary scale, worlds like the one under your feet right now. A rocky planet seems solid, permanent, safe, but strip away the atmosphere, the magnetic field, and the narrow temperature window that allows liquid water, and what you have left is a lifeless rock exposed to lethal radiation. Earth's magnetic field, generated by a molten iron core spinning nearly 3,000 kilometers beneath you, is the only thing standing between your DNA and a constant stream of charged particles from space. No field, no shield, no protection. And Earth is considered one of the more fortunate arrangements in the galaxy. The next layer up shows just how easily that fortune runs out. Layer 5 is the stellar layer, where planets become almost irrelevant next to the object they orbit. Our Sun alone contains 99.8% of all the mass in the solar system. Every planet, moon, and asteroid combined barely registers as a rounding error. At its core, the Sun burns at around 15 million degrees Celsius, fusing hydrogen into helium in a reaction so efficient. It has sustained a stable output of energy for over 4.5 billion years. But even a star this reliable follows a script that ends the same way for most stars its size: a slow expansion, a violent shedding of its outer layers, and a small, dense leftover core. If you have made it this far, drop a like, because the next layer up doesn't just end stars. It defines what happens to the space around anything massive enough to break the rules of geometry. That leaves us with layer 6, gravity's warping of space-time itself. Massive objects don't just pull on things around them, they physically bend the space and time nearby. A black hole is the most extreme version of this, a region where gravity becomes so intense that not even light can escape once it crosses a boundary called the event horizon. Sagittarius A star, the black hole at the center of our galaxy, has a mass about 4 million times that of our Sun, yet from Earth it appears roughly the size of a tennis ball placed on the surface of the Moon. No sound, no light, no signal ever returns from inside it. And here is where things become strange, because gravity at this scale is not the only force capable of rewriting reality. There is another layer that operates on a scale so large our entire galaxy is just a single grain within it. Layer 7 is galactic structure, the level where hundreds of billions of stars organize into a single rotating system. The Milky Way itself takes about 230 million years to complete one full rotation, meaning the solar system has only orbited the galactic center around 20 times since it formed. But galaxies don't just contain stars. They're held together by something we still cannot directly detect. Roughly 85% of all matter in the universe is believed to be dark matter, an invisible substance that outweighs ordinary matter by more than 5 to 1. We have never seen it, and we may never see it directly. But without it, galaxies like ours would fly apart. That single unseen ingredient becomes even more important once you zoom out past individual galaxies entirely. Layer 8 is the cosmic web, the largest confirmed structure in the observable universe. Galaxies are not scattered randomly, they cluster along enormous filaments of matter, separated by vast, nearly empty voids. Some of these filaments stretch for hundreds of millions of light years, connecting galaxy clusters like threads in a cosmic spiderweb, with dark matter acting as the invisible scaffolding holding the whole structure in shape. Stand far enough back, and even galaxies stop looking like the main characters. They become glowing nodes in something bigger, something that took over 13 billion years to form. And once you're looking at structure this large, a new question becomes impossible to avoid. What is actually driving all of it apart? Layer 9 is the expanding universe itself, driven by something scientists call dark energy. Right now, the universe is not just expanding, the rate of that expansion is accelerating. And dark energy is believed to make up close to 68% of all the energy in existence. We don't know what it is. We don't know why it exists. We only know its effects, a mysterious pressure pushing galaxies apart faster and faster as time goes on. Take everything discussed so far, every particle, every star, every galaxy, and understand that all of it is embedded in a fabric that is actively stretching beneath it right now while you watch this. But even an expanding universe assumes there's only one universe to expand. The final layer challenges even that assumption. Layer 10 is the multiverse, and it is the most theoretical, least confirmed layer on this entire list. Some models in physics, particularly those built from inflationary cosmology, suggest our universe could be just one bubble among an unknown number of others, each with potentially different physical constants, different forces, maybe even different rules for how matter behaves. We have never observed another universe, and we may never be able to, since anything beyond our own cosmic horizon may be permanently unreachable by any signal we could ever send or receive. No confirmation, no evidence, only mathematics that keeps producing the possibility over and over. And if it's true, then everything from the quantum foam to the cosmic web, everything covered on this list, could be nothing more than a single layer inside something infinitely larger. 10 layers, from a texture smaller than a proton, to a structure that may contain universes we can never reach. Somewhere in between, on a rock circling an ordinary star, in an ordinary corner of an ordinary galaxy, you exist just long enough to try to understand it. If you are not ready to leave this structure just yet, there is a full playlist waiting, exploring every one of these layers in far greater depth. Subscribe before the next layer gets discovered without you.